this is Kalpana here. In this video, we are going to solve a homogeneous differential equation. So let's get started. Problem: solve y dx plus 2 into square root of xy minus x into dy equals to 0. Solution: given differential equation is y dx plus 2 into square root of xy minus x into dy equals to 0. Let's consider it as equation 1. Okay. So, you can write this as y dx equals to minus of 2 into square root of xy minus x into dy, or 2 into square root of xy minus x into dy equals to minus y into dx. Okay, let it be, no problem. Then dy by dx equals to minus y by 2 into square root of xy minus x. Okay, so this is a function of y and x, right? Let f of x and y equals to minus y by 2 into square root of xy minus x. Then f of kx and ky will be, simply substitute x equals to kx and y equals to ky. Then you'll get minus ky by 2 into square root of, for x equals to kx and for y equals to ky, minus ky by 2 into square root of k into k square into xy minus kx, right? So you can also write this as k times minus y by 2 into square root of k square into square root of xy minus kx, right? Since square root of k square equals to, we know that square root of a equals to a power 1 by 2. Then you can write this as k square power 1 by 2. We know that a power m whole power n equals to a power m into n. Then this becomes k power 2 into 1 by 2 is 2 by 2, which is equals to k, right? So square root of k square is k. This becomes k times minus y by 2 into k into square root of xy minus ky. Okay, I like the same step here. K times minus y by 2k into square root of xy minus kx. Okay. So now you can take k common from the denominator. You'll get k times 2 into square root of xy minus x. K gets cancelled, which is equals to minus y by 2 into square root of xy minus x. Okay, which is a f of xy. Okay, this is a f of xy. So therefore, f of kx ky equals to f of xy. From this we can say that this function is a homogeneous function. Since we are having dy by dx equals to a homogeneous function, so we call it as homogeneous differential equation, which means that the given differential equation is a homogeneous differential equation, right? Fine. Now, let y equals to vx. Now differentiate it on both sides. With respect to x, dy dx of y equals to dy dx of vx. We know that uv whole dash equals to u dash v plus v dash u. Then this becomes dy by dx equals to dv by dx into x plus dx by dx into v. Then dy by dx equals to x into dv by dx plus v. Dx by dx is, or derivative of x with respect to x is 1. So you'll get 1 into v is v. Okay. You can replace dy by dx equals to the sum of two terms, or you can write this as dy equals to, simply take this dx to RHS, then you'll get x into dv by dx plus v into dx, which is equals to x dv by dx into dx plus v into dx. Here dx by dx is 1, so you'll get dy equals to x dv plus v dx. Okay. So now you can replace y and dy in the above equation. Then the above equation becomes vx into dx plus 2 into square root of x into x times vx minus x into, now replace dy by x into dv plus v into dx equals to 0. Then vx dx plus 2 into square root of v into x is v into x square minus x into x dv plus v into dx equals to 0. This becomes, you can split this as square root of v into square root of x square minus x, and remaining thing will be as it is. Since square root of x square is x, so you'll get 2x square root of v minus x into x dv plus v dx equals to 0. Okay. The next term we'll take x common. Then this becomes vx dx plus x times 2 into square root of v minus 1 into x dv plus v dx equals to 0. Okay, we have done nothing. Only we have taken x common from these two terms. Okay, and remaining steps will be, remaining terms will be as it is. Fine. This becomes vx dx plus x into x square into 2 root v minus 1 into dv plus xv into 2 root v minus 1 into dx equals to 0. Now take x common from all the terms. Then you'll get x times v dx plus x into 2 root v minus 1 into dv plus v into v times 2 root v minus 1 to dx equals to 0. From this we'll get v dx plus x into 2 root v minus 1 into dv plus v times 2 root v minus 1 . Don't get dx here, okay? Fine. Equals to 0. You're having inside the bracket. Okay? So get dx equals to 0. Fine. We know that square root of a equals to a power 1 by 2. Now replace square root of v. We'll get v dx plus x into 2 into v power 1 by 2 minus 1 into dv plus v times 2 into v power 1 by 2 minus 1 into dx equals to 0. Now we'll remove the brackets. Then v dx plus 2 into x into v power 1 by 2 into dv minus x into 1 x plus into minus minus x dv plus 2 into v power 1 by 2 into v, or you can write v as v power 1 into dx plus into minus minus v into 1v into dx equals to 0. Then v dx plus x into 2 into v power 1 by 2 into dv minus x dv plus 2 into v power 1 by 2 into v power 1. Bases are equal. Powers must be added. Then we'll get v power 1 plus 2 by 2, which is equals to v power 3 by 2. Okay, so this becomes v power 3 by 2 into dx minus v into dx equals to 0. Okay, here you're having plus v dx and minus v dx. Both get cancelled. Then this becomes, so take x and dv common from the first two terms. Okay, we have cancelled this, right? So this will be these two will be the first two terms. Then take x and dv common. You'll get x times 2 into v power 1 by 2 minus 1. Okay, plus 2 into v power 3 by 2 into dx equals to 0. Now what we are going to do is, we'll write all the functions of x and differential dx on one side and all the functions of v and differential dv on the other side. Okay, see. 2 v power 1 by 2 minus 1 by, take this to the first term into dv plus 2 by x into dx equals to 0. It's simple, right? Or we have to remove the function of x in this, from this. Okay, you're having the function of v, function of x into differential dv, right? So we need to remove x from the first term, and here you're having differential dx. We should have a function in x, but we are having a function in v. So we have to remove v power 3 by 2 from this term. So what you have to do is, you'll simply divide the whole term by x into v power 3 by 2. Okay, let's see what happens if we divide this equation by this. Then you'll get x into 2 v power 1 by 2 minus 1 into dv by x. Okay, okay, then this becomes x into 2 v power 1 by 2 minus 1 into dv by x into v power 3 by 2. Here x gets cancelled, plus 2 v power 3 by 2 into dx by x into v power 3 by 2 equals to 0. Here v power 3 by 2 gets cancelled. Finally, you'll get the same thing. Okay. Fine. Since you're having two terms in the numerator and one term in the denominator, so you can split this as, let's consider this part 2 v power 1 by 2 minus 1 by v power 3 by 2. Now you'll split the total fraction 2 into v power 1 by 2 by v power 3 by 2 minus 1 by v power 3 by 2. This equals 2 into v power 1 by 2 into v power minus 3 by 2 minus v power minus 3 by 2 is equals to 2 into v power 1 by 2 minus 3 by 2 equals to, here the bases are equal, so we'll add the powers. Okay, 1 minus 3 by 2 which is equals to minus 2 by 2 which is equals to minus 1, right? So we'll get v inverse minus v power minus 3 by 2. Okay, so we'll replace this by 2 v inverse minus v power minus 3 by 2. Then this becomes 2 into v power minus 1. You can write this as, okay, write as it is, 2 into v inverse minus v power minus 3 by 2 into dv plus 2 by x into dx equals to c. So here the variables are separable, right? So now we can apply or perform integration. When integral 2v inverse minus v power minus 3 by 2 into dv plus 2 into integral 1 by x dx equals to 0. This becomes 2 into integral v inverse into dv minus integral v power minus 3 by 2 into dv plus 2 into integral 1 by x into dx equals to 0, right? You can write v inverse as 1 by v, since we know that integral 1 by x dx is log mod x, okay, minus integral v power minus 3 by 2, and the remaining steps as it is, I can say simply. We have integral 1 by x dx is log mod x into dx, sorry not dx, plus integral constant, and integral x power n dx equals to x power n plus 1 by n plus 1 plus integral constant c for n not equals to minus 1. We are going to use these two formulas. Okay, and this becomes 2 into, apply this formula here, you'll get log mod v minus, for n equals to minus 3 by 2 which is not equals to minus 1. So we can apply this formula, you'll get v power minus 3 by 2 plus 1 by minus 3 by 2 plus 1 plus 2 into integral 1 by x dx is log mod y, log mod x equals to integral constant c. Then 2 log v minus v power 1 minus 3 by 2 equals to 2 minus 3 by 2 which is equals to minus 1 by 2. You get v power minus 1 by 2 by minus 1 by 2 plus 2 log x equals to c. Then 2 log v minus 1 by 1 by 2 is 2, right? So you'll get minus into minus 2 into, you can write v power minus 1 by 2 as 1 by v power 1 by 2 since x power minus n equals to 1 by x power n. So you could write this as 1 by v power 1 by 2. Okay, plus 2 log x equals to c. Now take 2 common from the first 3 terms, that is from LHS part. You'll get 2 times log v minus into minus plus 1 by, you're having v power 1 by 2, right? You know that square root of a equals to a power 1 by 2. So we can replace v power 1 by 2 by square root of v plus log x equals to c. If you take this 2 to RHS, you'll get log v plus 1 by square root of v plus log x equals to c by 2. Since c being integral constant, you can write c by 2 as c. Then log v plus 1 by square root of v plus log x equals to c. Okay, since we know that log a plus log b equals to log ab, then you can write log v plus log x as log vx plus 1 by square root of v equals to c. We are having y equals to vx. From this we'll get v equals to y by x. Now replace v by y by x. Then log y by x into x plus 1 by square root of y by x equals to c. In the second term, you are having, see here x gets cancelled. In the second term, you are having 1 by square root of y by x, right? You can write this as 1 by square root of y by square root of x, which is equals to square root of x by square root of y. right? So this becomes log y plus square root of x by square root of y equals to integral constant c. So you can maintain mod here or you can remove. Okay. Therefore, the general solution of the given equation is of 1. The general solution of 1 is log mod y or log y plus square root of x by square root of y equals to c. Or you can write square root of x by square root of y as simply square root of x by y. Okay? Fine. So this completes the problem. Hope you'll understand. We'll see you in the next video. Until then, bye bye.